Hi, in the previous tutorials, we have learned about the revenue function, the cost function, and also the profit function. So in this tutorial, we will learn about how to compute the maximum revenue, minimum cost, and also the maximum profit by using the second derivative test. Please refer to the lecture note for second derivative test method. Let's look at the first example. The total cost of producing Q units of a certain product is described by the function CQ, where C is the total cost stated in Rm. Determine the number of units Q that should be produced in order to minimize the average cost per unit. Right, so the keyword here is minimize. Always remember, whenever you see the word minimize or maximize, what you have to remember is the first differentiation, the first derivative of a function and equate it to 0. So here, you should replace it with the function. And what's the function that we want to minimize? Is the average cost function. So replace that with the average cost function. So now, average cost function is denoted as cost is C, average is that bar. And our unit now is not X, but it's in terms of Q. So we have to write C bar Q. So the function that we want to minimize, that should be written in this box, is the C bar, and in this bracket is the unit Q. I hope you understand what I mean here. So this means we want to differentiate C bar function and equate it to 0. It's like finding the stationary points that you have learned in the first lecture. Always remember, whenever we have minimize or maximize a function, you have to do this second method, which is by using second derivative test to check whether the function really maximizes or minimizes the function. So for this question, this is minimizing the average cost. Remember, for second derivative test, when it's minimized is when we're smiling, and this is the minimum point. So when we're smiling, that means we have a greater than 0 of the second derivative. So now we have to make sure that the answer for the second derivative, if we check, must also be greater than 0. Hence, your steps would be, the first step is to find what is the number of units that minimize the average cost. Second is to check whether that number of units Q really minimizes that average cost function by using the second differentiation. So from the first step here, what you obtain is the value of Q, the number of units. It's like finding your stationary points. After you have find dy over dx equal to 0, what you find after that is the value of x of your stationary point. So now, since the variable is in terms of Q, so that's why our final answer after we equate this first derivative to 0, the variable that we have found is Q. Alright, so the question here has given us the cost function, but we want to minimize the average cost function. So how to obtain the average cost function from the cost function? Remember the formula to find average is just a bar, and then we have this division, and the unit here is not x but q, so we write q below, and on top will be the cost function. So write the cost function on top, divide each of the terms with q. Now divide each of the terms with q and simplify, and you get this as your answer. After you have obtained your average cost function, look at the first step. It is to minimize the average cost. So now what you have to do next is to differentiate this average cost function. After you have differentiated that average cost function, equate it to 0. Now your q squared is equal to 500,000. So what is the value of q? It's just the square root of 500,000. Here, the question wants you to determine the number of units of Q that should be produced in order to minimize the average cost per unit. So the number of units here, when you press your calculator, is 707.106. So it's approximately 707 units. Please always check what the question wants. In this question, the question wants you to determine the number of units. So we are giving them the number of units. But remember what I have mentioned before. Whenever you do this first derivative, equate it to 0, you must also do the second step, which is the second derivative test. This is very important because you want to make sure whether this Q units is minimizing the cost or maximizing the cost. So if it really is minimizing the cost, then your second order differentiation must be greater than 0. So let's try to differentiate this one more time. Look at your C bar prime Q function and differentiate this. And then substitute your value of Q inside. Please substitute the value of Q which has not been simplified. So use third of 500,000 instead of 707 units. And then power it with 3. And now the answer is greater than 0. So it is minimizing the cost. Now please write your conclusion. Write something like minimum average cost and then state in words your conclusion. Before you write your conclusion, always check back the question. The question is asking about determine the number of units that should be produced in order to minimize the average cost per unit. So write your conclusion, 707 units from what you have obtained before. 707 units should be produced to minimize the average cost per unit. Next question. The average cost function and demand function in RM of a company that manufactures computer chips are: the first one is the average cost function. The second function is the demand function, or also known as the price demand function. Find the cost function. So in A, we have to find the cost function. The one given to us is the average cost function. So what is the formula? Remember, the formula of a average cost function is the cost function divided with x. So to find the cost function, just bring x to the left side and you have to multiply it with the average cost. Next question. Find the maximum revenue and the number of computer chips sold to achieve this. So what is this question asking for? The first question is asking about the maximum revenue. So this means we want to find what is the revenue. The keyword is maximum. Remember, whenever you see the word maximum or minimum, you must always remember to differentiate that function and equate it to 0. And what is that function that we want to maximize? It's the revenue function. So we have to differentiate that revenue function. But in this question, it's not the same as the previous question, where this question wants you to find the maximum revenue. So the answer that the question wants is in terms of the value of the revenue, and then the number of computer chips sold to achieve the maximum revenue. So the question also wants you to find what is the X that achieves this maximum revenue. Hence, for this question, we have to differentiate the revenue function equated to 0. From here, we will find the value of x. Next, substitute that x into the revenue function to find the maximum revenue in terms of RM. Well, whenever you have the first derivative and equate it to 0, you must do your second derivative test. Why? Because you want to make sure whether the value of x that we have just found in this first step is maximizing or minimizing the revenue. So since we wanted to maximize the revenue, what we must show is that in the second step here, it must be less than 0. And then you have to write a little bit of conclusion that this shows that it is a maximum revenue. Next question is finding the maximum profit. Also the same, the keyword here is maximum. Whenever you see the word maximum, minimum, maximize or minimize, Remember, what you have to do is differentiate the function once and equate it to 0. But what is the function that we want to differentiate? It's the profit function. Profit function is known as that pi function and equate it to 0. This is your first step. Your second step is you must always do the second derivative test to make sure whether the value that you have found here, which is the value of x that you have found from the first step, is really maximizing the profit. So here, what you need to show is that the second derivative must be less than 0 for it to be a maximum. Why? Because remember, when second derivative is less than 0, it's like you are having negative amount of money in your account, so you're sad, so that's your maximum point. Always try to relate what you have learned before so that it's easier for you to memorize. And in question C also, we want to find the maximum profit. So the question is not asking about the number of units that maximizes the profit, but the question is asking about the maximum profit. So after you have found that x, and after you have shown that the maximum really does exist, so we have to substitute that value of x into our profit function to find what is the value of that profit in terms of ringgit. The next question is the maximum profit if each computer chip sold is taxed 3 ringgit. Well, that's another story. Let me explain ABC first. Question A wants you to find the cost function, but the function given is the average cost, so write the formula of average cost first. Average cost is equal to cost function over x. Write cost function as the subject, bring x to the other side, x multiplied with the average cost function, and then write down your cost function. Next, multiply each of the terms with x. You have found your cost function. A is done. Next, question B. Finding the maximum revenue and the number of computer chips sold to achieve this. Like I have mentioned before, here, what we have to do is we have to find the revenue function. But what is the formula to find the revenue function? Please look back at your previous tutorials. I have mentioned the formula before. The formula is just x multiplied with the price demand function. So what is the price demand function? It's given to you 20 minus 0.001x. And then expand this function. Now you have successfully found your revenue function. But we don't want to find the revenue function. We want to maximize the revenue. So to maximize the revenue, remember it's the first differentiation and equate it to 0. And what is the function that we want to maximize? It's the revenue function. So just differentiate this revenue function, equate it to 0, and solve until you find your value of x. That value x will maximize the revenue after you have checked your second derivative test. The value of x is 10,000. Always remember, that is not enough. You have to always check whether this value of x maximizes the revenue or minimizing the revenue. Because remember, if you do the first derivative and equate it to 0, the answer might be a maximum or a minimum. For the point to be a maximum point, this is a sad face, so it must be less than 0. The second derivative must be less than 0. For minimum, it is a smiley face, so you're happy, so it's greater than 0. And your second derivative must be greater than 0 for minimum and less than 0 for maximum. Same concept applies here. Now check for your revenue function. Differentiate this revenue function one more time, and you see that the answer is negative. So when it's negative, this means that the maximum exists. Write your conclusion and check back your question. The question B wants you to find the maximum revenue and the number of computer chips sold to achieve this. Number of computer chips is the value of x, and we have found the value of x that maximizes the revenue. But what about the maximum revenue? This is just the value of the revenue with the number of units that maximizes that revenue. So substitute into the revenue function, and then press your calculator. Don't forget to write your units. Now, please write your conclusion clearly in words. Write something like that. Next question is to find the maximum profit. As we have discussed before, this means we need the profit function, and we have to differentiate that profit function to maximize the profit. So what is the profit function? It comes from the formula of revenue minus cost. You have found your revenue function in B. Write it down. 20x minus 0.001x squared. Subtract with your cost function, 1000 plus 2x. Expand and simplify, and this is your profit function. After that, you have to differentiate the profit function and equate it to 0. You differentiate this blue function, bring 2 to the front, multiply with negative 0.001, and then 18x will be just 18. Negative 1000 will be 0. So solve this till you find your x. The x is 9000. But remember, that's not enough, because we always have to check that it is maximizing the profit, not minimizing the profit. So to check, you have to do your second derivative test. This means you have to differentiate again. Differentiate this, and you will get a negative value. So when it's negative, you're set. So this is maximum. Write a little bit of conclusion here. Maximum profit exists. After that, check what the question wants. The question wants the value of the maximum profit. So the question doesn't want to find the number of units that maximize the profit, but the question wants you to find the maximum profit. So this means what is the profit that we earn from this 9,000 units sold. So just substitute that x value into the profit function. And the answer is 80,000 ringgit. Don't forget to write RM in front. Units are very important. Now, the next question wants us to find the maximum profit if each computer chip sold is taxed 3 ringgit. Each computer chip sold. So it's like our average cost. Average cost means that it is the cost incurred for each of the computer chip. So if each of the computer chip is being taxed with 3 ringgit, so this means our cost function, our average cost function, has been increased by 3 ringgit. Remember, because average cost function is the cost per unit. If you simply add 3 ringgit to the cost function that you have obtained in A, then that would be wrong, because the cost function in A refers to the total cost. So if you simply add 3 ringgit to the cost function, this is like a fixed cost of 3 ringgit, not per unit. Next, simplify your average cost function and then find your new cost function. Your cost function is just from the formula of average cost over the unit. So to find the cost function, just bring x to the other side. Multiply x with the average cost function. Expand. And this is your new cost function. I'm going to add a subscript of text underneath the cost function, which refers to the new cost function, so that you don't get confused with the cost function in A. The question wants you to find the profit function. So to find the profit function, we know that the formula is the revenue function minus with the cost function, but with the tax. So the new cost function with the tax will be obtained from this formula, but the revenue would still be the same function as before. Why isn't the revenue function changed? Because we still have the same price demand function. The price does not change, only the cost changes. Write down your revenue function that you have obtained in B question. Subtract with the new cost function. Expand and simplify. Next, we want to find what is the maximum profit. So whenever you see the word maximum or maximize. This means we have to differentiate the function one time and then equate it to 0. Differentiate this profit function, equate it to 0, and find your value of x. Next, you must check. So differentiate this one more time, and the answer is less than 0. Write the conclusion that maximum profit exists. Next, check your question. We want to find the maximum profit, so this means we want the value of the profit function. Now substitute the value of x into the profit function, and the answer is 55,250 ringgit. Write your units there, and then write your conclusion in words. So this would be the conclusion for question D. Please try out example 3 and also tutorial 6 and 7. Thank you for watching.